Okay, so now we're going to talk about the lab. So we're going to learn a bit more about statistics, actually fitting data to a curve, and then a little bit more about Excel. All right, so many times, you have some, well, like a plot, let's say distance in meters versus time in seconds. And, so basically, you're seeing how the distance changes with time. And, let's say we have something like that. That's the data. So we want to see if there's some kind of a relationship between the distance and the time. And the easiest one is a linear relationship. That's just y equals mx plus b. So, you want to see if there's a linear relationship. So, so how do you know if it follows a linear relationship? Well, look at it. It kind of sort of looks like a line, don't you think? Well, okay, if it looks like a line, that means it has a slope and an intercept. Well, how do you find the slope and the intercept? All right, so just kind of pretend that this is a piece of graph paper, and I have nice axes, And so how would you do it? Well, you could just kind of take a meter stick and, sort of kind of just do your best, right? But I mean, is that really how you want to do it? You want to just kind of wing it? Probably not, So there's an excellent way to do it, a quantitative way to do it, and it's called a least squares fit, a linear least squares fit. And this is what computers do, all right? So a computer will just give you the best fit to the data. And remember, computer does what it's told, right? So if you tell it to check for a line, it will do it. Okay, so if you check for a line, what will it give you? It will give you the parameters of the fit, right? It will give you the slope and the y-intercept. Now you have to be a little bit careful though. Again, computers do what they're told. So let's say you expect a line, and so you fit it to a line, but then just for fun, you want to see if it fits to a quadratic. Well, it'll do it, right? And it'll give you the A and the B and the C. It does whatever it's told, okay? But luckily, I'll talk about this a bit later. If you fit it to a line, it's going to give you how good a fit it is. If you fit it to a parabola, it's going to tell you how good a fit it is, and so you choose the one with the best goodness of fit, right? Okay. All right, so again, let me review. So you plot the points. I'll show you that in a minute. And then you say, Excel, I want you to fit the data to a line. So Excel does it. And it gives you the slope and the intercept. And then, as I was saying earlier, it gives you something called the goodness of fit. The goodness of the fit. And in Excel, it's called R squared. I don't know why. All right, R squared. And R squared goes between 0 and 1. If it's 0, it's a perfect fit to the data. If it's, what did I just say? I hope I just said if it's 1, it's a perfect fit to the data. If it's 0, there's no correlation with the data to the fit. Okay? All right, and like I said, you can also perform quadratic, power, you name it. I mean, Excel is fantastic. You can do all sorts of things. All right, so let's learn how to do it. All right, so step number one. Step number one is you enter your data, which I already did, right? And don't forget, when you enter the data, you want to label it properly, right? So you know what's going on later on. So this is the distance, I call it y in meters, and this is the time in seconds. Okay, so you just enter your data. All right, great. Now, we want to make a graph. And in Excel, graphs are called charts. Okay, fine, all right? So we want to insert a chart. So you go up here, and you want to insert, right? So we're going to insert, and then what do we want? We want a chart. Now you notice there's all sorts of different kinds of charts, graphs, right? I mean, look at all of these. So we're trying to plot, distance versus time. So that's called a scatter plot in Excel lingo. So we want this one right there. So you click on that. So you click on that one. See? Insert scatter, X, comma, Y. So you do that. Oh my gosh, now you get another choice. So it's your choice, Do you want just the data points plotted? Or do you want the data points connected with lines? Or do you want the data points connected with, smooth curves? Or if you don't want to see the data points, you just want the curves with the smooth curves or just a straight line. So you get to pick whatever you like. Isn't that awesome? And there's even more. My goodness gracious. All right. So, pick whatever you like. So I usually pick this one. But I don't have to. I just like it. Now, that wasn't supposed to happen, but that's all right. Okay, now what we have to do, we have to select the data. Okay, so you put your cursor somewhere in the chart, right-click, and it says Select Data. Well, by the way, I should tell you, I am not showing you the easiest way to do this. I'm showing you the most complicated way to do this. Why? Well, you'll see. All right, just trust me, because it's useful, right? And you're going to be using the complicated way most of the time, so that's why I'm showing you that. All right, so you want to select the data. So we click Select Data, and again, I'm showing you the hard way, so don't laugh, all right? So, okay, so we got to click Add because we want to, put the data. All right, you can give it a name if you want. I'm not going to bother. Okay, so then we want to give it the X values. Now here you got to be careful. You don't want to, we want the distance versus time. We don't want time versus distance, right? And so the X value here, we want this. So we're going to just select all those times. It's a real common problem. People forget which they're plot. They put the Y on the X and X on the Y. All right, so there. Okay, so we selected all of our X values. Now we go down here, and I don't know why that thing is in here. We want to get rid of that. So get rid of that, and then we select our Y values just by dragging. Okay? Just kind of ignore this, please. That's not supposed to be there. All right. Okay. Now you look at it. You say, let's see, did I do it right? Well, the time goes from 1 to 9. That looks good. The Y goes from 2 to like 18. So, okay, so I did it right. I didn't get mixed up. So I click OK. And then I go OK. Okay, I'm just going to get rid of this blue thing because it's bugging me. All right, there you go. All right, so there's the data, right, plotted. But, there's no title, there's no axis title, subtitles. We don't have the fit yet, so we got to do that, right? Okay, so let's make it a reasonable graph. And so you see on the top right here, it says Chart Elements. So we want to add titles and so forth. So you click that. Okay. Axes, yeah, we want axes, right? We want numbers on our axes. Axis titles, we want that. We want a chart title, and we want a trend line. Okay, so we got a lot of work to do. All right, so chart title, what do you want to say? Distance versus time. Okay, then this one is time. Oops. In seconds. By the way, you see, oh shucks. I goofed that up, huh? Time in seconds. You can see what I'm typing is up here. So it appears where you want it. Then over here, it's magically going to appear like you want it to appear, all right? So we want distance in meters. See? Okay, now the important thing. Okay, So now it looks nice, but now we want to do the fit, right? We want to do the fit. So here you go. So what you do is you right-click on any data point you want. It doesn't matter. Just any data point, you right-click on it. By the way, this is all for a PC. If you have a Mac, it's a little bit different. And I don't have a Mac, so you have to figure it out for yourself. All right. So Excel says, most people call this a least squares fit. Well, for whatever reason, Excel calls it a trend line. Okay, so trend line. Okay, so I click that, and look at all the choices you have. Exponential, line, log, weird polynomial, power, all sorts of crazy things. So we want line. And of course, Excel always tries to read your mind. And sometimes it works pretty well. So it recognizes the line, so it's already checked. Okay, now, not done yet. We want to see the result on the chart. So scroll down here, and you can see we want to have our equation displayed on the chart. We also want to see the r squared value on the chart. So we're going to check those two boxes. And that's it. Okay, so there it is. Now, I don't know about you, but that's a pretty poor place for the equation, right? Let's put it up here. So it's in a box, so you can just move it. Ta-da. There you go. All right, so there it is. Okay, that's all there is to it. All right, now, how do you learn how to do this? By practicing. So, just like last week, I have some Excel exercises for you. So let me show you. Let's go to Canvas. So this lab is well, lab 2, but it's also called stats 2, fitting lines. Okay, so statistics 2 and physics 121L fitting lines Excel exercise. So just like last week, please download that to your computer and do them all. Complete all of the exercises, and I'll publish this, and so I want you to check your answers with this. Now, we're going to be using this the whole semester, so you have to understand how to do it. It's as simple as that. Also, there are questions 5 and 6 on this exercise you must understand if you want to do today's lab correctly. So be careful, pay attention. Again, make sure you look at the answers. If you have any questions, contact me, contact our tutor. But 5 and 6, you have to understand. Okay, so after you complete this, I want you to save it, and that's part of your lab report, just like last week. All right, let's cut.